All right, so today we are going to go over rationalizing the denominator. Basically, taking the root out of the denominator. We are going to do that today. So I have 5 examples. Let's go ahead with the first one. 1 divided by the square root of 3. We want to get rid of the square root of 3. So what we do is we multiply the square root of 3 over the square root of 3. This is going to rationalize the denominator because the square root of 3 times the square root of 3 is equal to 3. These square roots cancel each other out. And 1 times the square root of 3 is the square root of 3. So that is how you do number 1. That's how you rationalize this one. Now number 2, the 7th root of 1 over k raised to the 3rd power. We can rewrite this as the 7th root of 1 over the 7th root of k raised to the 3rd power using the properties of the nth root, which I went over in another video. So that is what we can do with this one. And any root of 1 is 1. So this is equal to 1, because any root of 1 is 1, divided by the 7th root of k to the 3rd power. But we still need to rationalize the denominator. We can do that by multiplying. Well, we need to get rid of this, but we can do that by multiplying the 7th root of k to the 4th power by the 7th root of k to the 4th power. So why do we do this? Because when we multiply exponents 3 and 4, you add them. And 3 and 4 is 7. And if you know by the properties of the nth root, let's just take x for example. 7, the 7th root of x over the 7th root of x raised to the 7th power. Because these two are odd, these two numbers are odd, they're going to cancel each other out. So that is going to equal x, right? I went over that in another video. I'm not really going to go over that too much here, but that's just a basic idea. So, because 4 plus 3 is 7, and we need them to cancel out. So this gives us the 7th root of k to the 4th power over the 7th root of k to the 7th power. Using the property here, we cancel out the 7th root from the denominator. So this is going to leave us with 7, the 7th root of k to the 4th power over k. Like that. 7th root of k to the 4th power over k. That is how you rationalize number 2. Now number 3. This one's easier. 2 over the square root of 6x, 6 times x. We can do that by, again, using the same thing we did here, by multiplying what over what? Square root of 6x over the square root of 6x. Like that, just like this one right here. We're going to do that with number 3. So what does that equal to? 2 times the square root of 6x over, obviously the square roots cancel each other out, so it's just going to be 6x. So what do we notice here? We notice that we have a 2 and a 6, and the 2 divides into the 6. this can go into this basically 3 times. So we're going to divide 2 divided by 6, which is 3. So it's going to be, we're going to simplify this by basically dividing 2 from the numerator and the denominator. That's how we simplify it. This is going to be 6x over 3x, because 6 divided by 2 is 3x. So we divide 2 by both sides. 2 goes into 6 3 times. 6 divided by 2 is 3x. We can't really do an x with the 2, so 3x. 2 divided by 2 is obviously 1, so we don't really bother to put the 1 there, so it's square root of 6x over 3x. That is how we simplify this one. Now, number 4. Number 4. The fifth root of 1 over t to the third power. Again, we can reapply this concept to number 4. So basically, any root of 1 is always going to be 1. Non-negotiable. The fifth root of t to the third power. Sorry about that. The third power. So we can rewrite that as that. Again, we want to get rid of the power, the nth root from the denominator. We're going to multiply. Again, we use the same concept. What can we multiply to basically turn this 3 into a 5 and cancel out the fifth root? Remember, when we will multiply exponents, we add them. So we can multiply this by the fifth root of t over 2. Right? Because 3 plus 2 is 5. Again, on the numerator, the fifth root of t over 2. And that is going to give us 1 times the fifth root of t over t to the second power. That's the fifth root of t over t to the second power. Sorry about that. This is equal to, basically that's equal to the fifth root of t to the fifth power. This is odd, so they just give us t. So the fifth root of t to the second power over t, we can't simplify this any further, so that is going to be our answer for number 4, like that. Cool. Now we have number 5. Basically the same concept as this one. We're just going to do it over again. Just this time we have a 3 instead of a 1. So we can rewrite this as the fifth root of 3 over the fifth root of t to the third power. Again, we have to get rid of the nth root in the denominator. We do this by using the same concept here. We want it to be like that, so these two can cancel out, and we're just left with t. So let's do this. Again, we have the fifth root of what will give us t to the fifth power. That's going to be t to the second power. That will give us t to the fifth power when we multiply it with this. Again, same with the numerator. 5 times t to the second power. Now we multiply. We know the denominator is going to just give us this. It's just going to give us t because we saw it right here. It just cancels out. And we know it's going to this is not 5 times the square root of 3. This is actually the fifth root of 3. Sorry, I didn't write it too well here, but We multiply it, so that's going to be the fifth root of, we need to multiply what's inside now. So 3 times t to the second power, you multiply those together to get 3 times t to the second power. So we have 5, the fifth root of 3t to the second power divided by t. That is how we rationalize the denominator. So that is all I have today. That is how you do this, and yeah.